Welcome in. Today, we are tracing the absolutely fascinating 25-year evolution of wireless data. We're going to take that confusing alphabet soup of tech jargon and turn it into a clear, awesome story of human ingenuity. Seriously, we'll look at exactly how we ditched the physical cables and managed to conquer the invisible airwaves all around us.
So here's our game plan. 1. The birth of wireless. 2. The frequency wars. 3. The dual band breakthrough. 4. Managing crowded airwaves. And finally, 5. The future with Wi-Fi 7. Let's get right into it. Right off the bat, it really helps to translate those super intimidating 802.11 engineering standards into the simple consumer names we actually use every day. Going from Wi-Fi 0 back in 1997 all the way up to Wi-Fi 7. This evolution perfectly maps out our insatiable, growing need for speed over the decades.
Section 1. The birth of wireless. Escaping the cables.
Picture this. It's the late 90s, and simply sending data without a physical cable plugged into the wall, it felt like absolute magic. Wi-Fi 0 laid the foundation for this back in 1997. It operated on the 2.4 gigahertz band and gave you a whopping maximum speed of, well, just 2 megabits per second. Now, obviously that was totally useless for streaming, and it was mostly just good for basic data exchange between computers. But hey, it successfully proved a massive concept. Data could reliably travel right through thin air. Just 2 years later, in 1999, Wi-Fi 1 bumped things up to 11 megabits per second. This was huge. It finally made wireless internet practical and affordable for everyday homes and schools. Suddenly, we could actually connect our laptops and printers without tripping over physical wires strung across the entire living room. But there was a hilarious and honestly super frustrating catch. Your brand new, cutting-edge wireless internet was sharing the exact same airspace as early Bluetooth devices and, get this, your kitchen microwave. Yeah, heating up a snack for lunch could literally cause enough interference to completely knock out your internet connection. Wild, right?
Section 2. The frequency wars. Speed versus distance.
To solve that microwave-induced traffic jam, engineers had to hunt for some different invisible airspace, basically kicking off a battle of the bands. But it came with an ultimate trade-off. You could either take the slow, crowded country road of 2.4 gigahertz, which gave you really great range, or you could jump on the fast, completely empty 5 gigahertz highway. The catch? That 5 gigahertz highway couldn't pass through solid walls very well at all. And this divide completely defined the next generation. Wi-Fi 2 adopted that 5 gigahertz band specifically for enterprise offices, places where raw speed mattered way more than punching through walls. Meanwhile, Wi-Fi 3 brought that same incredible 54 megabit speed to the home-friendly, wall-penetrating 2.4 gigahertz band in 2003, making it the absolute standard for early home networks. Looking at how things moved from 1997 to 2013, the internet went from a cool novelty to an absolute daily necessity. Consumer needs evolved so incredibly fast that engineers were practically forced to push standard after standard out the door, just trying to keep up with our rapidly growing digital appetite. Which brings us to Section 3, the dual band breakthrough, using both roads. By 2009, Wi-Fi 4 did something brilliant. It stopped forcing our devices to choose between those two roads and just started using both frequencies at the exact same time. By combining the 2.4 and 5 gigahertz bands into a single dual-band network, routers suddenly achieved these incredible theoretical speeds of up to 600 megabits per second. To make that massive leap, Wi-Fi 4 introduced MIMO. That stands for Multiple Input, Multiple Output. Think of it like a highly efficient air traffic controller. It used multiple antennas all at once to drastically improve range, cut down on that pesky interference, and for the very first time, make things like HD video streaming and online gaming truly reliable. A real game changer. Section 4. Managing crowded airwaves. The smart home era. As we rolled into the 2010s, the main problem wasn't just raw speed anymore. It was the sheer number of smart devices fighting for space in our homes. In 2013, Wi-Fi 5 focused entirely on the 5 gigahertz band to achieve a massive theoretical speed leap, up to 6.9 gigabits per second. I mean, that is a completely different universe compared to where we started. And this staggering bandwidth is exactly what finally allowed our modern smart homes to actually work. We're talking homes packed with dozens of connected gadgets, laptops and intensive online gaming consoles, all functioning smoothly without that constant, infuriating buffering we all hate. To achieve this smart home harmony, Wi-Fi 5 brought in MU-MIMO, or multi-user MIMO. It's a genius feature. It basically ensured that your laptop downloading a massive file wouldn't suddenly ruin the connection of the family TV trying to stream a movie. It lets several devices share the bandwidth simultaneously without stepping on each other's toes. But, our digital spaces just kept getting more and more crowded. So just 7 years later, Wi-Fi 6 arrived, pushing speeds up to 9.6 gigabits to serve high-density areas. Think about crowded apartment buildings, busy corporate offices, or airports, places where dozens, if not hundreds of devices are constantly competing for the exact same invisible airspace. Wi-Fi 6 managed this chaotic crowd using a technology called OFDMA. It's a brilliant feature that basically slices the existing wireless airspace into even smaller, hyper-efficient lanes. This way, everyone's data gets through without causing a massive traffic jam. It even scheduled connections strategically to help save your smartphone's battery life. Pretty smart. But incredibly, even with all of that hyper-efficiency, we still needed more space. Enter Wi-Fi 6E in 2021, which opened up an entirely brand new, totally empty 6 gigahertz highway. This was purpose-built for zero-latency virtual reality, real-time video conferencing, and pristine 4K streaming, offering drastically less interference than absolutely anything that came before it. Section 5. The future. Wi-Fi 7. So here we are, standing right at the bleeding edge, looking at the standard that will totally redefine what we consider possible in wireless connectivity. Wi-Fi 7, or 802.11b if you want to be technical, builds on absolutely everything we've just discussed. It adds cutting-edge features like 4K QAM to vastly increase data capacity and introduces multi-link operation. This allows your devices to stitch multiple frequency bands together simultaneously, pushing data throughput to absolute extremes. The result of all these compounding innovations, from avoiding microwaves back in 1997 to slicing up radio channels today, we're looking at a projected mind-bending speed of over 46 gigabits per second. Think about that. We started with 2 megabits that couldn't even stream a simple song, and now we're faced with just immense possibilities. With 46 gigabits per second traveling invisibly through the air, right into the palm of your hand, the only question left to ask is, what are you going to build next?